With this particular project, one of the things I want to do with the Sidewinder X1 printer is test the level of overhang that the machine is comfortable or capable of printing accurately and consistently. So essentially what I've done is I built this model, and the first thing I did was to import the test cube, and the idea being that I'm working to that particular scale because I don't want it to be too big, because I don't necessarily want to waste plastic. I just want to be able to create an object that is of reasonable size for me to be able to test this overhang accuracy. Now these two bottom shapes were very easy. I clicked on add and then mesh and then cube, and then I scaled the cube upwards like that, and then like that, and that gave me my base layer. And then the other thing I did was to rotate it like that, so it's basically 90 degrees standing up, and then I resized it accordingly so that I then be able to get the accurate size. So that gave me my base effectively. And then what I did is I created another cube. Just resize that, basically like that, and then put it into position and made it a little bit flatter, so it's more kind of rectangular than square. And then when I got that into position, I duplicated it and then shrunk the size of it so that it was less tall, about half height, and then duplicated it again so that it then I'm basically got one on top of the other. And then once I've got that one on top of the other and they're all perfectly aligned, is I selected both of those and then Control C, Control V, so that's copy and paste, and then drag to the right, Control C, Control V, copy and paste, drag to the right, copy and paste, drag to the right, copy and paste, drag to the right. So it gives me all of these uprights effectively. So now what I'm going to do is I'm going to go through each one and I'm going to rotate it. So I'm going to rotate the X axis by 10 degrees each time. So this one is going to be perfectly upright. This one is going to be 10 degrees. This next one is going to be 20 degrees. This next one is going to be 30 degrees. And then 40 degrees. 50 degrees. 60 degrees. 70 degrees. 80 degrees, 90 degrees. So it's going to be an interesting test because I'm not expecting it to be able to cope with these angles. 100 degrees, 110 degrees, and then 120 degrees. I suspect it's probably around degrees that the printer will be able to support, and then basically without any supports in place it shouldn't be able to print these. Now I'm not going to leave it like that. Basically what I'm going to do is I'm going to drag each one over so that it extends from, so the base of this overhang here basically meets the upright here, so that every overhang base has its base within the upright for support capability, and then the overhang will extend over, so we'll get this wrap like that, but it'll be from this point, and then we'll be able to see what the machine is capable of printing accurately using this particular model without supports and with supports. So I'm just going to tidy up the model now, so this will to move everything into position, so I won't get you to wait for that, but as you can see that's the bulk of the model, and I'll come back and show you the rest in a moment. So the first thing I'm going to do is to move all of the overhang pieces into a central position in relation to the upright beneath it. So I'll just do this approximately initially, and then I can do it a bit more accurately in a moment. And then what I'll also probably do is reduce the height of the uprights so that it's as kind of smooth as possible when the overhang meets the upright. And also, as I get to the end here, what's going to happen is that the uprights won't meet the overhang, so I need to adjust the height of those as well accordingly. So I don't necessarily want to waste plastic or filament by having these too tall. There's no point printing them too high when it's the overhang that's the most important. So essentially what I'll do is I'll reduce the height. So if we bring this down a bit, because we know this one's going to be fine anyway. And because this is just going into this base, it doesn't matter how tall that is, so I can just move it down as opposed to actually adjust the height, so that's okay. So there we go, so that's met that overhang quite nicely. Do the same with this one. So again, just make it meet there, so that's a nice meeting point. Reduce this one as well, down to there. Get a bit closer to this one. Reduce that down. So we can see this is where we're starting to get the overhang overlap. So if I bring it down too low, then we've got that problem there. So what I could do is bring that bit up a bit more, but also then probably bring this back. And then this down like that, and that way it meets a little bit more cleanly like that. I've got a bit of a ridge there, but it'll be interesting to see when we get into detail whether it'll actually print that ridge or not. So the only problem with doing it by eye is sometimes when you move it by the circle in the middle, so that you're adjusting all axes in one go, you can sometimes get that issue where it gets a bit too low or too out from one angle, but that's okay. And then if we adjust the height to meet at this particular point, like that, and also come in a little bit, and then we'll stop that sticking out the back, and then come down like that, and then also forward, and then down. That way we meet that very neatly then, so the overhang is coming from just the top like that. So I'm going to have to accept some form of ridge either on one side or the other, but what I'll do is I'll make it this side to see how that comes out in the actual print itself. So the idea is not that this is going to be absolutely perfect, but it is enough so that it gives us an idea of whether this overhang prints or not. So there we can see everything meets quite neatly, and probably what I'll do again, because the upright here isn't that high, so what I'll probably do is just reduce these as well, because it'll take time to print all of these, so there's no point spending unnecessary time, and also with this layer as well, because if this is going to take a few hours to print just for the sake of having a base for it to sit on, then I might reduce that as well. So what I'm going to do first of all is export this. I'll get rid of the cube, and I'll export this as it is, and then load it into Ultimaker Cura, get some idea how long this will print or take to print, and then I'll make further adjustments to see what I in terms of balancing the print time against how much filament's going to be used against the effectiveness of the test. So I'll just load this into Cura and let's see what this says. Imported it into Cura, and as we can see, Cura is starting to give us warnings here that this overhang is unsupported, and that makes sense based on what I expected really, because this is straight up, this is 10%, 20%, 30%, 40%. So as soon as you get over 45%, we can see that there's no support underneath it. So that gives us a warning that there might be problems. Now, with the normal settings, you would click support, and then it would create supports in order to support that overhang. But what I want to do with the first one is basically try it without supports, just to see what happens and when it starts to lose, because if you think about it, you've still got plastic underneath plastic for it to potentially build upon. So it's going to be interesting to see whether it can actually print this one at 50, this one at 60, this one at 70, and where it gets to the point where it just cannot support it anymore. So if we slice this, we can see that the model is 7 centimeters by 14 centimeters by 26.2 millimeters high. So what I might do, and this would take 1 hour 56 minutes, use 4 grams and take 1.24 meters of filament. So what I'm going to do now is I'm just going to make some adjustments just to probably shave a couple of millimeter off the base, shave a couple of millimeter off the thickness of this main support, and then I may drop the support height and then bring everything down just so that it's not so high, because it doesn't need to be 26.2 millimeters high. It only needs to be as high as it needs to be in order to just get these overhangs to try to print. So if that shaves off a little bit of filament and a bit of print time, then that's kind of all the better really. So I'm just going to do that now, and then we'll re-export the STL. So here we are back in Blender, and now what I'm going to do is just refine the model slightly so that it's not quite so big, not quite so wide, so that it doesn't take quite so much print time. Just want to get some idea. So that's in Blender units, so we can see. So that's 5. So if I reduce that to about 2 or something like that. So what we can do here is we go into scale, and then basically we can reduce the height of this slightly like that, and then that should meet the bed okay. So we can see that's where the base of that particular upright is, so that's still within that model or that object, so that's absolutely fine. So then what we can do is if we reduce the height of this, because it doesn't need to be that high, and then we can move that. That's probably enough. So then we can move that down, and then basically back into the base like that. Just make sure that meets okay, and select all of these. So that's all of those selected. I could have selected them from here, but it's much quicker just to do this select and then multi-select them all, and then I bring them all down like this. So the overhangs, basically, as long as it has a bit of an upright, then that's sufficient, because it's basically it's the overhang we're testing, not the printing of the upright itself. I could reduce the height of some of these others a bit further along, because these don't need to be that high. So if I can just, if I select these ones, and then we'll bring those down a bit as well. Making sure it's not coming out of the bottom there. And then I'll select that one and that one. Bring that down a bit. So again, we're not aiming for perfection of everything being exactly the right height. So it's not, we're not really aiming for perfection in terms of getting everything equal with one another. As long as it meets the objective of the test and allows us to see whether the overhang will print, then that's really all we need to do. And hopefully this will save a bit of print time as well by doing this, just because this upright doesn't need to be as tall. We can probably bring this one down a bit, this one down a bit. That's probably okay. And then the thickness of this, it probably doesn't need to be quite so thick, so we'll bring that in. And then that's almost as thick as the uprights themselves, which is okay, which is fine. So that's probably enough, because we've shrunk it down, we've reduced the height, we've reduced the width, reduced the width of the base, so that's probably fine. So what I'll do now is I'll re-export this as an STL file, and then we can load that back into Cura, and then we'll see how that has affected the print time and the amount that it's going to print. Just take that one down a bit more. So there we go. So file, export, STL, select our overhang file. In fact, I'll call this overhang 2 so that it's reduced size. Click on export, and that's it. So now we can load it back into Cura. So we'll click this object, the original object, press delete, so that's gone. Click on open, overhang 2, and there's our overhang. So we can see that the warning goes off at around 50% onwards again, just like it did previously. And we click on slice. So this time it's 1 hour, so it's much better. 2 grams, so half the weight, and then it's 0.66 of a meter, which is pretty much half the length. So that's going to be 71 millimeters by 14 millimeters by 18.2 millimeters high. So I think that's fine for our model. I think that's perfectly acceptable. I could again reduce the height of these, but I'll leave everything as it is. So what I've done here is I've actually adjusted the first upright. It just bugged me a little bit that it was so low in comparison to the other uprights. So I went back to Blender, increased the heights, resaved the STL file, and then just reloaded it into Cura. And one of the nice things is it recognised that the object had been modified, the original file, and it asked me if I wished to reload it, which I said yes. I clicked on reload, and there we go, there's the updated model. So even though this isn't meant to be a test of perfection, not everything needs to be the same height or length, it just bugged me a little bit that it was so low, and that's fine now. So in terms of print settings, we could go to custom. We can see that we've got our layer height. So a lot of these are the defaults that I just accepted in the original Artillery Sidewinder profile configuration. I did reduce the print speed, I think, down to 50 millimeters a second, just to kind of increase accuracy. We've got the printing temperature of 200, which seems to be kind of the average with all of the different filaments I'm using anyway. And the build plate temperature is 60 degrees, and that seems to have given me good adhesion to the bed, so it kind of everything seems to stick nicely and be consistent for printing. So I've just left that as it is. Infill density, I've left that at 20%, and if we go back to our basic settings, so I've left the profile default and the infill default, as you can see from the custom settings, and so in this particular test I'm not going to select support because I want to see what it will print and how it will print without support. It might be a bit of a mess when it gets to this end, but we'll see. If necessary, I'll abort it, but we'll see how it goes. So we'll click on slice, and just that, in fact, adding that little bit extra at the top there has added an extra minute onto the print time, which is interesting. it's interesting to see the difference it makes in terms of one slight change and how it can affect the print time. So 1 minute and a little bit extra filament, as you would expect. Okay, so I save that disk and then we'll have a look at and see how it comes out on the printer. And here we are in time-lapse mode, and for this particular print we're going to be using ICE Filaments Precious Pink, and it's a really nice vibrant colour, and I've used it on a couple of projects already and I really like it, and the test cube came out well. But one of the things I have noticed is that the temperature I think might be a little bit too high for this particular filament, and it causes it to almost leak. So the base of the test cube was a bit molten and it kind of bled into each other where the brim goes around it. And I think this is a skirt, if I remember correctly, on this particular model, and I think where that's at the bottom where it's kind of pulled away, I think that might be because it was a little bit too hot. But the overall model itself seems to be coming on quite well. The main support running through the model looks good, and you can start to see the uprights being printed, and overall from this perspective everything looks okay so far, but we'll only really know how things are going to come out when it's finished printing and when we've let the bed cool. So now the bed is cool, we can have a look at our overhang test in a bit more detail. So one of the things I noticed first of all is that the brim at the bottom, basically it was starting to get a bit tied up with itself. I did try and pull it away, but it didn't seem to adversely affect the print in any way as it's building its base, which is fine. A little bit of extra filament here, just as it was coming away after the last bit of the print. I can pull that off and tidy it up. If we get rid of this base, this brim, just pull that away as best I can with one hand. Okay, so this is really, really interesting. So obviously when the slicer Cura was looking at this, it said anything over 50% it wouldn't be able to print, or it gave a warning, a red warning, because of the overhang. But even though we didn't use supports, I'm just absolutely amazed at how well that's come out. And I can only presume that because we're printing at a very low resolution, or high resolution I should say, but a low number, 0.12 I think was in the profile, it must be just enough to actually allow the print to have enough plastic as it's extruding to build on. So obviously right at the end here, where we've got is it like 100, 110, 120%, it's fallen away, which is to be expected because there was just nothing for it to stick to, and without a support in place there was very little for it to print upon. But in terms of my expectations and it being able to print an overhang, that's just exceeded my expectations, because I had no idea it would be that successful. And it gives you a greater idea of what type of prints you could print, especially if they've got overhangs or sticky out bits, that would print probably successfully, or relatively successfully, even if you don't use supports. So I think that's really, really amazing. And okay, it's a little untidy in places, but I suppose the model was quite challenging in a way, because our uprights were quite narrow. It was having to do lots of juddery movements to go from one section to the next section to the next section. I think possibly the print temperature might have been a little bit too high with this ICE Filaments Precious Pink. I've noticed that previously when the brim at the bottom has kind of bled into the base. So it would be really interesting to redo the same print with the same model but with a slightly adjusted temperature, and I think I might do that, because it'll be interesting to see by doing all these tests which is the optimum setting. But that is just absolutely amazing. I'm just over the moon with that. I'm just really, really impressed by how much it can do on its own without additional supports or without some kind of consideration in the model for the overhang. So that's very, very impressive. Very impressive indeed. So I hope you found this test interesting. I have, certainly. As I go through this journey with 3D printing, the more I use the machine, the more I challenge it with these types of models, the more I learn. So if it's helpful to others, then that's fantastic, because that's what this is all about, helping each other. So thank you for watching.